Hello everyone, welcome to our channel codersarcade. In today's video, we will be talking about arrays in C. Before starting with today's topic, let me request you to please share and like our videos with your friends and family, and also subscribe to our channel codersarcade so that you get notifications about our latest updates. So let's get started. So far, we have used only the fundamental data types, namely character, int, float, double, and variations of int and double. Although these data types are very useful, they are constrained by the fact that a variable of these types can store only one value at a given time. Therefore, they can be used only to handle limited amounts of data. In many applications, however, we need to handle a large volume of data in terms of reading, processing, and printing. To process such large amounts of data, we need a powerful data type that would facilitate efficient storing, accessing, and manipulation of data items. C language supports a derived data type known as array that can be used for such applications. So, what is an array? An array is a fixed size, sequenced collection of elements of the same data type. It is simply a grouping of like type data. In simplest form, an array can be used to represent a list of numbers or a list of names. Some examples where the concept of an array can be used are as follows. List of temperatures recorded every hour in a day or a month or a year. List of employees in an organization, list of products and their cost sold by a store, test scores of a class of students, list of customers and their telephone numbers, or else table of daily rainfall data and so on. Since an array provides a convenient structure for representing data, it is classified as one of the data structures in C. There are many other data structures like lists, queues, and trees. We will also be discussing about this in our next upcoming videos. So we will be mainly talking about arrays in this video. So there are many types of arrays. We can use arrays to represent not only simple lists of values but also tables of data in 2, 3 or more dimensions. In this and the upcoming videos, we will be discussing how to use it to create and apply the following types of arrays, which are one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. So let us first talk about one-dimensional arrays. Okay, let me give you an example. Suppose I want to add three numbers. Let me think about three variables. In my mind, I might be thinking of A, B, and C as the three variables. And what did you think about? You might also have thought about A, B, and C, right? Or else we can think about X, Y, and Z. Now the question is, why are we only thinking about A, B, C, or X, Y, Z? The reason behind this is A, B, C, or X, Y, Z follows a certain pattern, and it is very easy to remember this kind of patterns. So, whenever we think of variables in a pattern, then it is very easy to remember those patterns because it continues in a serial number or a pattern. Suppose A, B, C, D, E, or you can say W, X, Y, Z, etc. It becomes very easy to remember. Now, if I ask you to add, suppose 100 numbers, in that case, it will be very difficult to think of 100 variables at the same time because it will be very time consuming and it will fill the program with clutters and it will be very messy, right? So what we can do is, in this kind of situations, we can use arrays. So let me show you how an array looks like. An array can be represented like this. It will have the data type, then we will write the variable name followed by square brackets, and then we can give the number of elements. And you can either assign the length of the array at the beginning, or you can leave it blank. It can be of two types. Now the question is, if I assign the length of the array, then it will be something like this. This will have 10 number of elements, as you can see in the figure. Now the question arises, how we can access the elements in this array. For that, we have the idea or process of indexing. The indexing in C programming starts from 0. As you can see, the first element will have the index 0, and followed by it will go on till the last number. So if we are having 10 elements, then the last number will have the index 9. 10 minus 1 is equal to 9 because it is starting from 0. So if we want to access the first element, we can write a of 0. And if we want to access the last element, we can use a of 9. So this is how you can access the elements in an array. Now let us move on to the editor so that we can understand more about this one-dimensional array. I am going to my editor now. So as I told you, I will write my main function and followed by this curly braces. Here I will assign the array, and in this program I will show you how to calculate the average of 10 numbers. For that I will be using a one-dimensional array, which is also like a list. So this is the syntax of writing an array. Int a of, you have to give curly braces, and inside it I will assign the length of the array, which is 10. Then I will give the column. Now, as I told you, to access the first item in the array, you can do it by using the indexing like a of 0. So like this, you can access all the items in the array. Now you can assign values to the elements of the array like this. If I say a of 0 equal to 56, in this way I can assign values to the elements of the array. And if I say a of 9 is equal to 90, in this way I am assigning a value 90 to the last element of the array or the 10th element of the array. So for the time being, let me take an input from the user for all the elements. For that, what I have to do is I will use the printf function, and here I will write enter the 10 elements one by one. And now I will give a escape character /n so that I get the output in the next line. And please remember, you have to give the semicolon here. Now the question is, how do I take the input from the user? For that, I will be using a for loop. For I equal to 0, but the question is that I have to now assign this variable. Otherwise, I will be encountering an error. So for that, I am taking the I variable. So now I have 10 elements. So I can do it in two ways. I equal to 0. I less than 10 I can write, or else I can write I less than equal to 9. Both are correct. So I am using the first one, I less than 10. Then semicolon, I plus plus. And now I will be taking the input from the user. For that, I will use the scanf function. And here I will take the quotes and I will write %d, comma, and this is the ampersand. This is for the address. And here I will write a of I. So in this way, the elements entered by the user will be stored in the variable a, which is an array, one by one. Now I have to give the semicolon. So in this way, I will be getting all the elements input from the user and will be storing them in the array a. Now, first of all, to find the average, I have to calculate the sum of all the numbers or the elements in the array. For that, I am taking one more variable, which is sum. So for this, I have to take another for loop. Here also, just because there are 10 elements, I will be using the same logic, I equal to 0, I less than 10, I plus plus, and here I will be using this logic, sum equal to sum plus a of I. So in this way, all the elements will be added one by one because of this for loop. It will start from the first element and it will keep on calculating till it goes on to the last element. But for that, initially I have to initiate the sum value to 0, which I will be doing now. As you can see here, I have done it to 0. Now I have to calculate the average. For that, let me take another data type, which is float, and I will take the average variable and semicolon. And after this ending of the for loop, I will take average equal to sum divided by 10.0. Why have I taken 10.0? Because when we divide integer by integer, we will be getting an integer value. I want it to satisfy for float also. That's why I am taking 10.0. I have taken 10.0 because I have 10 number of elements, and the formula for average is sum of the number of elements divided by the number of elements. So now I will print the average by using the printf function, and here, just because my data type is float, I have to use %f. So I will write the average is %f, and then I will give a comma and call my average variable. So now it's done. So this is the total code. Now let me run it for you so that I can show you the output. I'm running it. You can see there is an error. Okay, I have to give a semicolon here. I have given a comma. Sorry for that. Now let me run it once again. And here also I have to give one semicolon. You people need to remember that you have to give semicolon everywhere. So let me run it again. And yes, it's asking me to provide the elements one by one. Let me zoom it for you. And I'm giving the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and say 10, and press enter. You can see it's calculating the average, which is 5.5000. So I'll press enter, and this is how you can calculate the average using an array. This is a one-dimensional array. In my next videos, I will be talking about two-dimensional arrays and multi-dimensional arrays as well. So here I want to tell you one more thing. You have to remember the syntax. As you can see here, array is represented by the variable name and followed by the length of the array. And if you don't assign this length, then you can put as many numbers as you want. But if you assign this length, then you have to provide 10 elements or less than 10 elements. If you provide 10 elements, then it's okay. If you provide less than 10 elements, suppose if you're providing 2 elements, then first 2 elements will be the elements provided by you, and the other 8 elements will be by default 0. And if you provide more than 10 elements, then you will encounter errors. So this you have to keep in mind. So this is how you can work with arrays. In today's video, I will be talking about arrays in C programming. In my earlier video, I have already discussed about arrays. So in that video, I told you about one-dimensional arrays. In this video, I will be talking about the remaining topics. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Codus Arcade and press the bell icon so that you get notifications about our latest updates. Thank you. So let's get started. As I told you, my today's topic will be arrays in C programming, as you can see here. So I told you there are three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional, or it can be multi-dimensional arrays. In our earlier video, we talked about one-dimensional arrays. So today we will be talking about two-dimensional arrays. So what are two-dimensional arrays? Two-dimensional arrays are used to represent tables or matrices. So let me give you an example so that you can understand better. Here in the figure, you can see this is a matrix. It has rows and columns. There are particularly 2 rows and 4 columns here. And in this type of array also, we have the method of indexing, with the help of which we can refer to a certain row and column. So as you can see here, the columns will have the indexing like this: 0, 1, 2, and 3. And at the same time, the rows will also have the indexing like 0 and 1. Because there are 4 columns, therefore indexing will start from 0 and end at 3. And because there are 2 rows, the indexing will start at 0 and end at 1. Suppose we want to represent the marks of 2 students. So in that case, we can do it in this fashion, as you can see here. So 10, 20, 30 and 40 are the marks of student 1, and 50, 60, 70 and 80 may be the marks of another student, which is student 2. So let us move on to the editor so that I can show you how to write a program on representing this matrix or table with the help of two-dimensional arrays in C programming. So now I'm moving to my editor, and here you can see I will start with the main function, and then I'll press enter and give the curly braces. So here starts our main function. Now I will take the array variable name, let it be marks. Here you have to follow this syntax. You can see here I am using 2 square brackets, and inside that I will give the row number and the column number, as I showed you in the example. So this is how you can do it. Now I will press the equal sign, and now I have to give the elements inside this array. So here I have to give one more curly braces so that I can provide the elements. So here you can see I will be giving the numbers as 10, 20, 30, 40. So this finishes my first row. Now I will write the second row. Say 50, 60, 70, 80. So now I'm done with the assigning of the elements. Now to print these elements, I need 2 for loops. So for that, I have to initiate 2 loop variables. Let it be I and j. I'm giving one comma. Here I will give I, comma, j. So these are my loop variables. Then finally I have to give my semicolon. So now I'm ready with my assigning of variables. Now to represent this, as I told, I have to use 2 for loops, which is also known as the nested for loop. So I'm writing the syntax for I equal to 0, semicolon, I less than 2, this is for the number of rows,
semicolon, I plus plus, small I plus plus. Then here I'm opening the curly brackets so that it becomes easy to understand. And inside it, I will take another for loop. And here I will take j equal to 0. This is for the number of columns. And semicolon, j less than 4, because it will start from 0 and go on till 3. 0, 1, 2, 3. So there are 4 columns. And then I will give the semicolon, then j plus plus. And here inside this for loop, I will again try to print the array now. So for that, I will use the printf function. And here I will write %d, comma, then I will write marks. And here you should notice that I'm writing I and then here j. So in this way, I will be able to represent the marks. So here I have to give the semicolon to end it. And as soon as I have written the first line, I want to give the control to the next line. So for that, what I will do is I will take one more printf statement, and here I will give an escape sequence, which is /n. So this will give the control to the next line. And now, with the help of this, I can print the two-dimensional array. So let's run my program and see whether it is correct or not. I'm running it. So now you can see on running it, I'm getting the output, but there is no space in between the elements. For that, what I can do is I can give one space here so that I get a proper output. Now let me run it once again. And now you can see there is a space between the marks of the two students, 10, 20, 30, 40, 50, 60, 70 and 18. So this is how you can do it. So this is a basic example of two-dimensional array. You can see here, this is the syntax. This is the data type, this is the variable name, and this, just because it is two-dimensional, I am writing 2 square brackets, and inside it I am giving the row and the column values. So this is how it is done.
In today's video, we will be talking about the next topic, which is character arrays and strings. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel codersarcade and press the bell icon so that you get notifications regarding our latest updates. Thank you. So let's get started. As I said, our today's topic is character arrays and strings. So let me start with the definition of a string. So a string can be defined as an array of characters, or we can also say that a string is a collection of characters. So as you can see in the screen, A is a character and it can be denoted like this inside quotes. B is also a character and it can be denoted like this inside quotes B. And if we have to define a string, then as I said earlier, string is a collection of characters. So here, as you can see, H is a character and high is a string inside quotes. So as I said, if we write a collection of characters inside quotes, this will be termed as a string. So let us see or learn how we can declare strings. So let us move on to the declaration part of strings. As you can see in the screen, the declaration can be like this: char string name followed by the length. Here char is the data type, and then we have the name of the string followed by the length. And let me give you an example. Suppose char string name followed by inside square brackets 100. So this example represents a string of 100 characters. The length can be different depending on our choice. So as we know the declaration part, and as I have showed you in the figure, in case of strings we always use the character data type. So in the example you can see that we have used the character data type. Now after the declaration part, let us move on to the initialization part. So here there are two ways to initialize strings. The first way is using single character constant. Let us check an example so that I can tell you better about this topic. So here is the example. Char a of 10 is equal to inside curly braces hello, and just see how I have written the example. HELLO. All these individual characters are inside quotes and they are separated by commas. And finally, at last, we have /0 inside quotes. This /0 is known as the null character. This null character is actually a character which marks the end of the string. It tells the compiler that the string has ended. So this is the first way of initialization of strings. As I told you, it is using single character constant. Now let us move on to the second type of initialization of strings. The second type is using string constant. So let me show you another example so that you can understand the second type. The example is char a of 10 is equal to inside quotes hello. Here we are using a string constant. So in this case we do not have to use curly braces, or we do not have to separate individual characters inside quotes. We can write the entire string inside quotes. So this type of initialization of strings is known as initialization using string constant. And please remember, in case of string constant, we do not use the null character because the null character is placed automatically by the compiler. We do not have to place it. So after we have known about initialization of the strings, let us move on to the next topic, which is accessing of strings. So as we already know from our previous videos, we can access integers with the help of %d. Similarly, we can access floats with the help of %f. In case of string also, we can use this method, which is %s. With the help of %s, we can access strings. So, as you know how to access strings, initiate strings and declare strings, let us move on to the editor so that I can show you a simple example with the help of which you can understand about strings more. So now I will be going on to my editor. Here I am inside my editor, and now I will be writing the program for you. Let me write the header file, which is #include stdio.h. Then I will write my main function and inside my main function I will write the data type for my string, which is char. Then I will take a of length, suppose 10. Then I will declare it as hello. Okay, and then I will give the semicolon. Then this will be a simple example so that I can show you how to print this string. Now I will use the printf statement and I will print the given string is percent, as I told you earlier, it is s, and then I will give comma a and semicolon. So with the help of this I can print the string. So let me run my program so that I can show you the output. I will run it for you now. So as you can see here, it prints the given string is hello. So this is how you can print it. But let me tell you one more thing. In this case, I am using the string constant. But I will also show you the other one, which is the single character constant. For that, I have to change the syntax a little bit. I will give a curly braces and inside it, I will separate each character with the help of quotes. Let me show you how. I'm giving comma and again I will give quotes. So with the help of quotes, we can separate each single character constant. And now let me show you one interesting thing. As I told you, the null character defines that the string has ended and it tells the compiler this is the end of the string. Now let me assign the null character here /0. So this is the null character. I will give a comma and after that this O I will keep at last, as you can see here. So now, as I told you, this null character will actually tell the compiler that the string has ended. So when I print this, I get only 4 characters, which is H, E, L and L, because this null character will be the end of the string and this O will not be printed. So let me just run the program so that I can show you the output. As you can see here, it says the given string is HELL. So as I told you, this null character will define the end of the string. Now if I put this O before this null character, and give a comma here, now you will see that hello will be printed. Let me run it. You can see here hello is printed. So this is how we can use single character constants or string constants and we can print the strings. So this is a basic example. In today's video, we will be talking about the topic reading a series of words from a terminal using the scanf function. For this, we will be using arrays. So before starting the video, I would like to request you people to please like and share our videos and also subscribe to our channel codersarcade and press the bell icon so that you can receive notifications about our latest updates. Also, share our videos with your friends and family and those who are willing to learn programming. So let's get started. As I told, today's topic is reading a series of words from a terminal using the scanf function. So let us directly go on to the editor so that I can show you the program. I am going to my editor now and here I will start with the main function. So inside the main function, I will create my variables. So I will take the character data type and then I will take the variables. Say word1, and the size should be say 20. Similarly, I will take 4 or 3 other variables. Word2, 20. Word3, 20. And word4, the length is also 20 in this case. Then I will give the semicolon, and I have to remove this semicolon and give a comma here. So now I have declared the variables which are arrays. Then here I will use the printf statement and I will write enter the words one by one, and then I will give the /n so that I can go on to the next line. So here, to take the user input from the user and store it into the variables which are word1, word2, word3 and word4, I have to use the scanf function. So let us use it, scanf. And now inside quotes, as I told you in my earlier video, to read the characters or the strings actually, we have to use %s, and then I will give a comma, and here I will call my word1 variable. Similarly, I will do it for the other ones as well. I will just copy this code and then I will paste it 3 times. So here I just have to change it for word2, word3 and word4. Then after that I will use a printf statement so that I can take the control to the next line. For that I will use /n. So here I have to give a semicolon, and also in all the earlier cases I did not give the semicolons. Let me give it for you. So now it's done, and now let me print the words. For that I have to use the print statement once again, and here let me print the words. For that I will write word1 is equal to %s. As I told, for strings it is %s. Then I will use the next line /n. Then again I will write word2 is equal to, similarly I have to write %s. Then I will take the next line command, which is the escape character /n. Then here after this I will give comma, and then I will call my word1 and word2. So this is done, and let me just copy it and paste it here so that I can change it for the word3 and word4. This will be word3 and this will be word4, and here also let me change it word3 and word4. So this is it guys, this is the total code. Now here I will run it so that I can show you the output. This will actually read a series of words from the terminal using the scanf function. So let me run it, and it says there is an error. Yes, you can see here there is no semicolon, so there is an error. Let me run it once again now, and okay, you can see It's asking me to enter the words one by one. Let me give the words. Let me give the name of our channel. Say coders, then arcade. Then we are learning about C programming, right? So let me write C and then programming. So when I press enter, you can see that word 1 equal to coders, word 2 equal to arcade, word 3 equal to C, and word 4 equal to programming. So this is how we can read a series of words from the terminal using the scanf function. So here I have given it in different lines. Let me show you what happens if I give all the words in a single line. I will press enter and let me run it once again. The shortcut is F9 and let me zoom it. To zoom it, you should hold the control and scroll the mouse up button. So now let me give the words in a single line. Say I will write the same thing. Coders arcade, C programming. And if I press enter now, you can see even if I give the user input in the same line, I'm getting word 1 equal to coders, word 2 equal to arcade, word 3 equal to C, and word 4 equal to programming. So it doesn't matter if we give the input in the same line or different lines, it will be stored in the variables word 1, word 2, word 3, and word 4. So in this way you can read a series of words from the terminal using the scanf function, as I have shown you in this program. You can see these are the scanf functions that I used. So let me zoom the program for a little bit so that you can see the program code clearly. So this is my entire program code. So this is how you can read a series of characters from a terminal using the scanf function. And here we are using the character data type and we are using word 1, word 2, word 3 and word 4, which are arrays, as variables. So if we take more variables, we can read more number of words. In today's video, we will be learning about how to perform linear search in C programming. So before starting the video, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel Coders Arcade and press the bell icon so that you receive notifications about our latest updates. Thank you. So let's get started. As I told, our today's topic is performing linear search in C programming. So let's start. Let us take 5 elements in an array. So, if we take 5 elements in an array, the array size will be 5. So, this gives us our first variable, which is n. So, here in this case, I am taking the size to be 5. So, n is equal to 5. Now, let us take the 5 elements. So, let me take the elements as 12, 15, 16, 17, and 3. So, these elements will take up the index like this: a of 0, a of 1, a of 2, a of 3, and a of 4. Since the indexing starts from 0 and there are 5 elements, it will start from 0 and it will end at 4. So a of 0 will be 12 and the last element will be a of 4, which is 3. Now, how to do the linear search? For that, we have to take a number. So let us search the number 17 in our case. So for that, we have to take the next variable, which is key. And as I said, we are searching the number 17. The value of key here will be 17. And let us take another variable flag, which will be initialized to 0. And as soon as we find our number, the flag value will be changed or updated to 1. But if we don't find the value of flag, it will be 0 itself. So the key value will be compared to all the elements in the array. First of all, key will be compared with a of 0, then a of 1, then a of 2. And as you can see here, the key is 17 and it is equal to the element a of 3 in our case, as you can see in the array. Now, as soon as we find the key and it is matched with the element in the array, what will happen is we will have to update the value of flag to 1. Then we have to get out of the loop. For that, in C programming, we have the break statement. With the help of the break statement, we will come out of the loop. And then we will compare the value stored in the flag variable. If the value of flag is 0, then we will say that the number that we were searching was not found and the search was unsuccessful. But if the value of flag is 1, then we can say that the number which we were searching in our array has been found and we will print the search has been successful. So that is it, guys. This is the logic behind the program. Let us move on to the editor so that I can show you how to write the program and execute it. So now I will be moving on to the editor. So let's get started here as I am in my editor. First I will write a comment. Search. And I will close the comment box. And then I will start with the header files. stdio.h and conio.h. After that, I will start with my main function. And inside the main function, I will start with initializing the variables. Here, first of all, I will take the array, which is a of, let the size be 10. Then I will take the size of the array, which is the variable n. And then I will take the variable key as I mentioned. Then I will take the flag and I will initialize it to 0. And finally, I will take the loop variable to iterate over the loop, which will be I. Then I will give the semicolon and I will now write the print statement. Here I will tell the user to enter the array limit or size. Then I will use the /n so that I can take the output in the next line. Then I will use the scanf function so that I can take the input from the user. I will use the %d to take the integer value from the user, and then I will store it in the variable n. And after this, I will again use the printf statement so that I can take all the elements in the array one by one. So for that, I will use the print statement and I will tell enter %d so that I can read the n value elements one by one. And after this, I will again use the /n so that I can print the input given by the user in the next line. And after this, I will give the n variable. So with the help of this, Now I will use a for loop, and here I will take the loop variable I equal to 0, then I will take the condition I less than n, which will be less than the size of the array. Because it starts from 0, then it can go on till 4, and we will be getting the number of elements. I have to give a semicolon here and here also. Then I will increment the value of I. Here I will take a curly braces, and here inside the curly braces I will use the scanf function so that I can read the input from the user. I will write %d, comma, and a of I, so that I can store the numbers provided by the user in the array. So after that again I will use the printf statement so that I can ask the user which number he or she wants to search. So here I will write enter the number to be searched, and again I will use the /n so that I can go on to the next line, and here I will use the scanf function. Then I will write %d, this value will be stored in the key variable. Then here now comes the logic of the program. Here I will use the for loop, and the condition will be the same. I is equal to 0, I less than n, I plus plus. Now I will use the if statement, and here I will check if a of I equal the key value, then inside the braces I will write, as I said, flag value will be updated to 1, and then as soon as we have found the number we will break out of this loop. And finally, after I come out of this for loop, here now I will check the value of flag. If the value of flag is 1, then I will print it is successful, or else if it is not 1, then I will print it is not successful. So we can do it in this manner. If inside brackets we will write flag, that means if the value of flag is 1, then inside the braces I will print number found, searches successful. Then I will give the control to the next line by using the /n, and here I will use the semicolon. And after this I will go out of this if, and I will use the else for the other condition. Here inside brackets I will print the opposite, which is number not found searches unsuccessful. Or you can say search failed, whatever you want, that doesn't matter. full stop. And here also I will give the control to the next line so that it looks good. And here I have to give the semicolon, and now we are done. So this is the entire logic of the program, and now let me show you by running it. I will run it for you now. So here let me zoom it for you, and it says enter the array limit or size. Let me take it as 5, and as I wrote in the program, here it says enter 5 elements one by one. Now I will take the elements, say 12, 36, 6, 17, and say 8. And now it will ask for the number to be searched. Here let me take as 17 and press enter. And now you can see it says number found, search is successful. So that means we have been able to find this number 17 which is present in this array. Now let me show you another example where I will search for a number which is not present in the array. So I'll press any key and then I will run it again by pressing the shortcut F9. And here, let me zoom it for you. And here I will give the enter the array limit or size to be again 5, say. And here I will give the elements to be 1, 2, 3, 6, and say 9. And now let me search for a number which is not present in the array. Let it be say 4, and let me press enter. And here you can see it says number not found, search is unsuccessful. So this is how we perform linear search with the help of C programming. So this is the entire program, as you can see here. As I told you, first we take the array, then the array size, and then we initialize the key value to the number to be searched, and then we initialize the flag value to 0, and this is the loop variable. Then we iterate over the loop, and if we find that the number is found, then we update the value of flag to 1, and then we print number found. And if it is not 1, then we update by saying number not found, search is unsuccessful. So this is the entire logic. I hope you understood. In today's video, we will be talking about the topic binary search in C programming. So before getting started, I would like to request you people to please like and share our videos with your friends and family, and also subscribe to our channel codersarcade so that you receive notifications regarding our latest updates. Thank you. So let's get started. So as I told you, our today's topic is binary search in C programming. So for that, let us take an array. So inside the array, let us take the elements one by one. Let me take 10 elements. So the elements are 3, 5, 7, 9, 13, 17, 33, 47, 88, and 95. So before starting this search, I want to mention one very important thing, which is binary search can be performed only in a sorted array. So as you can see in the screen, this is a sorted array. All the elements are arranged in an ascending order. So here you can see that the indexing starts from 0 and goes on till 9. So here the array size is 10. And let us consider the key value to be 17, which will be the element that we will be searching by performing binary search. So we are supposed to find this key value 17 in this given array. Now the question arises, how will we perform this? So let me tell you the solution. We will first divide this array by finding the mid value or mid term. The formula to find the mid value is mid equal to start plus end divided by 2. So as you can see in the diagram, the start value is 0 and the end value is 9. So the mid value formula will be 0 plus 9 divided by 2, and it will be 9 by 2, which can be approximately termed as 4. So now we can say that 17 or the key value is greater than a of mid. That means 17 is greater than a of 4. And in the array we can see that 17 is greater than the a of 4 element, which is 13. So now what we will do is we will change the formula for start, which will be start is equal to mid plus 1. That is, the mid value was 4, so it will be 4 plus 1 is equal to 5. And we already have the end value, which was 9. So end equal to 9. We are skipping the first 5 elements because the key value 17 is not present there, as you can see. So now again let us find the mid value in this new array. Mid is equal to start plus end divided by 2. So our new start is 5 and the end value is 9. It will be 5 plus 9 divided by 2 is equal to 14 divided by 2, which is 7. Now let us check once again. 17 is less than a of mid, or 17 is less than a of 7. Or we can say 17 is less than 47, which is true. So now, because it is less than the mid value, what we will do is we will change the formula for end. End equal to mid minus 1. That is 7 minus 1 is equal to 6. So we have start equal to 5 and end equal to 6. And this is our new array. So we are skipping this end part because key value is not present here, or it is less than this part. So now again mid is equal to start plus end divided by 2 is equal to 5 plus 6 divided by 2 is equal to 5 approximately. So now let us check once again. 17 is equal to a of mid. 17 is equal to a of 5, or we can see here that 17 is equal to 17. This means that our search has been successful, so we can print it. If we don't find the element, in that case we will print search is unsuccessful. So now this is the entire logic of performing binary search to find an element in an array. And as I told you, binary search can only be performed in a sorted array. So the array has to be sorted first, and then we can do the binary search. In my case, I will be taking a already sorted array, and in the next topic I will show you how to sort arrays with the help of bubble sort and other sorting algorithms. So now let us go on to the editor so that I can show you the program to implement binary search. So here I am going to my editor, and let me start by the header file #include stdio.h, which is the standard input output library. And then I will start with the int main, and inside my main function I will declare my variables. which are of the integer data type. So I will take the loop variable I, then I will take the start variable, then I will take the end variable, then I will take the mid variable, then the array size n, then I will take the key to be searched, and finally I will take the array, say of 100 size, so that I can sort it for more numbers. And now I will use the printf function, and here I will ask the user to enter the number of elements, and to take the control to the next line I will use the /n. And now using the scanf function I will take the input from the user and store it by using the %d and n. So now I have taken the number of elements from the user. Now I will use the printf statement or function to tell the user to enter the elements one by one. So I will use enter %d integers one by one, and then here also I will use the /n so that I can give the control to the next line, and after the comma I will give the n value. So now again I have to use a for loop here so that I can take the input from the user. I equal to 0, I less than n, I plus plus. Inside the curly braces I will use the scanf function, and here I will take the input from the user and store it by using %d. A of I. So this is the way how I can store the input from the user, and after that I will go out of this for loop, and again I will use the print function, and here I will type enter the value to be searched, and here also I will use the /n character, and here I will take the user input by scanf %d, and I will store it in the key variable. So first I have to initialize the values for start and end. So I will take start to be 0, and because the indexing starts from 0, so I have to take end equal to n minus 1, and now I have to write the formula for mid, which is mid equal to start plus end divided by 2, and you have to be very sure about this bracket, because otherwise it will give errors or you will not be able to implement it correctly. After that I will be using a while loop, and the condition will be while start is always less than equal to end, then here I will write the condition. If a of mid is less than my key value, then inside the curly braces, as I told you in the explanation, my start value will be start equal to mid plus 1. So this is the condition, and I have to take another condition, which is else if I find the key, then I have to write a of mid equal the key value, then here I will print %d found at location %d. I will tell you what I am trying to do, and let me give a full stop, and after that let me again use a escape character, which is /n, so that I can go on to the next line, and after the comma I will use key and then my mid plus 1, because if I have found the key, then I will say key is found at the mid plus 1 location. And after this, if I have already found the key, then I have to go out of the loop, for which I will be using the break statement. And now, if this condition is also not satisfied, if I have not found the key, then what I have to do is I have to again compare the other condition, which is the last one, which is else, and inside the brackets I have to write end equal to mid minus 1. So this is done, and finally I have to again update the value of mid, which is mid equal to start plus end divided by 2. Now comes the condition where I will not be finding the key. Then this will be a unsuccessful search, and for that also I have to use the print function. So it will be like if start greater than end, then inside curly braces I will use the print function, and here I will type not found, and then I will use %d isn't present in the list, full stop, and then I'll use the /n, and after the comma here I will take the key variable. So this is done, and because I have taken int main, as you can see here, I will use the return 0 statement at last. So this is the entire logic, and now I will show you by running it. So let me run it for you. So it says there is an error. Okay, the error is I have only written print, so it should be printf. Now it's correct. So let me run it so that I can show you the output. So here I'm running it for you. Okay, so it's asking me for the number of elements. Let me take 5, and here I will take the 5 integers 1, 2, 3, 4, 5, and now it's asking me to find the value. Let the value be, say, 5. So it is in the array, as you can see. This is the last one. So when I press enter now, it says 5 found at location 5. So this is working all right. Now let me show you for the unsuccessful search, where I will not be giving the element which is present in the existing array. So here, let me run it once again, and let me take, suppose, 6 elements, and 1, 2, 3, 4, 5, 6, and you have to keep in mind that you are always giving sorted array only, otherwise it will not work. And if I press enter now, and it's asking me for the value to find, let me take 9 and press enter. So here you can see, let me zoom it for you. It says not found, 9 isn't present in the list. So this is the logic behind this, guys. So here is the entire program. I hope you have understood. This is how we can perform binary search in C programming.
In this video, we will learn about sorting algorithms in arrays in C programming. We will be sorting the array elements, and for that we will be using the selection sort algorithm. Before starting the video, I would like to request you people to please like and share our videos with your friends and family, and subscribe to our channel Coders Arcade so that you receive notifications about our latest updates. Thank you. So let's get started. First of all, we will try to understand about the logic associated with selection sort, how to use it in our program, and then we will write a practical program and understand its execution. So let's start. Let us look at an example. Consider an array of 5 elements. The elements are 5, 3, 8, 2, 1. Then their index numbers will be 0, 1, 2, 3 and 4. In selection sort, one by one indexes are selected and the smallest among all the elements is placed or shifted to that particular index. In this way, the index number goes on increasing till the last index, and finally we get our sorted array. In this example, we can see that we have 5 elements and their indexing is from 0 to 4. At index 0, the element is 5, so it will be selected and then the smallest element in the array will be chosen. As we can see, the smallest element in this array is 1. Now, these two elements will be swapped and 5 will go to 1's place and 1 will go to 5's place. Now, we will have a new array. At index 0, we have 1, then 3, 8, 2, and at index 4, we will have 5. Now, the index will change from 0 to 1 and we have 3 at index 1. Again, the smallest element will be selected and interchanged with the number or the element 3. Here, 2 is the smallest element, so 2 and 3 will interchange their positions. Now, the new array will look somewhat like this: 1, 2, 8, 3 and 5. Now, the index number 2 will be selected and here we have the number 8. Again, the smallest number will be selected, which is 3 in this case, and the numbers will interchange positions. Now, the new array will look like this: 1, 2, 3, 8 and 5.
Similarly, after the next pass or iteration, the array will look like this: 1, 2, 3, 5 and 8. So finally we have our sorted list. This is the basic principle on how selection sort works. One by one, the indexes are selected and the smallest among all the elements is placed or shifted to that particular index. In this way, the index number goes on increasing till the last index, and finally we get our sorted array. Now let's look at one more logic here. In the array, the index numbers are from 0 to 4, and in the selection sort algorithm, it's selecting till index 3. So it is selecting the index which is 1 less than the highest index. It's because on selection of the second last index, we already have the sorted array. So you need to remember this step because it will help you in the implementation of the for loop in writing the C program. Now let us go to our IDE so that we can implement this example on selection sort by writing a C program. So as you can see here, I am inside my editor. So I will start by including the header file. Then I will start with my main function. Here I will start declaring my variables. First I will take the loop variables I and j. Then I will take the size of the array to be size. Then I will take a temp variable for swapping. Then I will take one more variable index so that I can store the index in that. And then I will take one variable, the minimum one. And finally I will take my array of size say 10. Now I will use the print statement so that I can take input from the user. So I will ask the user to enter the size of the array. Here I will use the scanf function so that I can read the size from the user. Now I will use another printf function so that I can tell the user to enter the elements one by one according to the size. So I will use printf, and here I will type enter %d elements one by one, and I will be giving the /n escape character so that it goes to the next line. And here I will use a for loop so that I can take input from the user of all the elements in the array. For I equal to 0, I less than size, I plus plus, and here I'll use the scanf function to read the user input. %d, comma, and I will save it to the array by using the address operator. So this part is done. Now I will again use one print statement so that I can print the unsorted array. And again I will use a for loop so that I can display the unsorted array. I equal to 0, I less than size, I plus plus, and I will use the printf function so that I can print the unsorted array. %d, oh I have to give the quote also, %d, and so that I can give a particular distance between the elements, I will use the /t, which is the tab character, and then I will use my a array by declaring it and calling it a of I. So this is done. With this we can take a input of the size from the user, and we can also print the unsorted array. Let us check it. Before that, I will just use one more thing, return 0, because this will be returning integer values. So let us run it and check if it is correct or not. I'm running it. Okay, it is asking me for the size of the array. Let the size be 5 as we saw in the example. I'll press enter. Okay, it's printing some junk values. You can see here 1733 something. Let me check what is the error. First of all, let me just close it. Okay, I can see that I have used %d, but I have not given the variable name. So here I'll give a comma and give size as the variable. So now let us check it once again. Okay, I will zoom it and let the array size be 5. Yes, now it's correct. Enter 5 elements one by one. So let us take the elements to be 5, 8, 3, 2 and finally 1 and press enter. Okay, now you can see the unsorted array is 5, 8, 3, 2, 1. So it's working till now. Let us go on with the logic of the program now. So after this print statement, let us start with the logic now. So I will have to take two for loops, one to select the index and one for comparing the values of the initial index and the index after that. So for that, I will be taking the for loops as for I equal to 0, I less than, and as I told during the selection shot, the index less than the highest index is selected and we get our sorted array. So it should be size minus 1. So you need to be careful about this. And after that, I will give the increment I plus plus. So here, this is the outer for loop. Inside that, I will take my minimum value to be equal to a of I, and I will take the index to be I. Then we can go on and write the next inner for loop for j equal to 0. And here I need to tell you something, because this outer loop will actually be for the iteration of the indexes, and we need to check from the first index to the next index. So for that, we have to go to the next index. How we can do it is, we have to write not j equal to 0, we have to go from j equal to I plus 1. Then our condition here will be j should be less than the size, so that we can go on till the last index. And finally, it will be j plus plus. So this is how we go into the inner for loop, and here I have to use the conditional if statement, where I will be checking the value of the next index with the minimum value. So for that, what I will write is, if a of j is less than min or the minimum value, then inside the if statement, what we will do is, if it is less than the minimum value, then we will change the value of minimum. So we can do it by writing min equal to a of j. And finally, we shall also have to change the index. Here index is I, so now the index will become index is equal to j. And now we will go out of this if statement, and also we will go out of this inner for loop, and then when we have found the minimum number, we have to swap it or interchange it with the first number or the number at that particular place. So for that, we need to write a statement like this. So as I have declared the temp variable already, so we will write temp is equal to a of I. Then we will write a of I is equal to a of index, so that we can change it. And finally, we will be interchanging this. So it will be a of index is equal to temp. So this is a basic swapping algorithm. I hope you all understand this. So with this, we have come to the end of the logic in this program. And finally, what I will do is I will go out of this outer for loop, and here I will use the print statement, and I will print the sorted array. So for that, I will use the /n first, and then I will write the sorted array after selection short is again /n, and finally for this also we have to use a for loop for I equal to 0, I less than size I plus plus, and inside this we will be printing our sorted array. So again I will be using the printf function, and inside this I will print %d, and to give a space between the elements I will use the /t comma, and I will call the a of I, so that I can get all the elements in my array. So with this I am done, and this is the entire program. So let me now run this so that we can see if it is working properly or not. So I will be running it. So let me zoom it for you, and here it's asking me for the size of the array. Let it be 5, and yeah, it's asking me for the elements, 5 elements one by one. So I'll give 5, 8, 3, 2, 1 and press enter. So you can see the unsorted array is 5, 8, 3, 2, 1, and after the selection sort is done, it says the sorted array after selection sort is 1, 2, 3, 5 and 8. So our program is working perfectly. So this is how you perform the selection sort algorithm. In this video, we will learn about one of the sorting algorithms in arrays in C programming. We will be sorting the array elements, and for that we will be using the bubble sort algorithm. Before starting the video, I would like to request you people to please like and share our videos and subscribe to our channel codersarcade and press the bell icon so that you receive notifications about our latest updates. Thank you. So let's get started. First of all, we will try to understand about the logic associated with bubble sort, how to use it in our program, and then we will write a practical program and understand its implementation and execution. So let's get started. Let us look at an example. Consider an array of 5 elements. The elements are 13, 24, 36, 17 and 12. Then their index numbers will be 0, 1, 2, 3 and 4. We will be arranging this array in ascending order. So the final result after bubble sort will be the following array: 12, 13, 17, 24 and 36. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. This swapping is done by comparison. In this example, we can see that we have 5 elements and their indexing is from 0 to 4. In the first iteration, at index 0, the first element is 13. So it will be compared to the next element, which is 24, and then the greater element between the two will go towards the right if necessary. But we can see that 13 is smaller than 24. Therefore, no swapping will happen. Then 24 and 36 will be compared, and as 24 is smaller than 36, it will remain in its same place. Then 36 will be compared to 17, and since it is greater than 17, they will interchange positions. Then 36 and 12 will be compared, and since 36 is greater than 12, they will again interchange positions. Thus, after the first iteration, 36 has reached its desired position and the array will look like this: 13, 24, 17, 12 and 36. Now, in the second iteration, 13 will be compared to 24. Since 13 is less than 24, they will stay at their original positions. Now, 24 will be compared to 17. Since 24 is greater than 17, they will swap positions. Now, 24 will be compared to 12. Again, as 24 is greater than 12, they will interchange positions. Then 24 will be compared to 36, and as 24 is less than 36, both of them will remain in their original positions. So after the second iteration, the array looks like this: 13, 17, 12, 24 and 36. In the third iteration, 13 will be compared to 17. They will remain in their original positions since 13 is less than 17. Then 17 and 12 will be compared and they will interchange positions as 17 is greater than 12. Then 17 will be compared to 24 and they both will remain in their original positions because 17 is less than 24, and 24 and 36 will also remain in their same positions because of the same condition. So after third iteration, the array will look like this: 13, 12, 17, 24 and 36. In the fourth iteration, 13 will be compared with 12, and since it's greater than 12, both the elements will swap positions. In this way, after each iteration, the greatest element in the array gets bubbled up to its desired position. Therefore, this algorithm is known as the bubble sort algorithm. Thus, you can see that after the fourth iteration, we have got our sorted array, which is 12, 13, 17, 24 and 36. This is how the bubble sort algorithm works. Now let us go to our IDE so that we can implement this example on bubble sort by writing a C program. So as you can see, we are inside our IDE and let's start writing the program. I will start by including the header file and then I will start with the main function. Here, let me start declaring the variables. First, I will declare my array. Let the array be A and the size be 10. Then I will take a variable to store the size. Let it be n. And then I will declare a variable temp so that I can swap the variables. And then I will take my loop variables. So let it be I, J, K and L. And finally the semicolon. Here, first of all, I will use a print function so that I can tell the user to enter the size of the array and the slash n character so that the control goes to the next line. And I will use the scanf function now so that I can store the size of the array into a variable. So it will be %d comma and the variable will be n. Then again I will use the printf function so that I can tell the user to enter the elements one by one. Enter %d elements one by one, and then again the slash n so that I can go to the next line. And finally here I have to give the variable name, which is n. And here, to read the input from the user, I have to use a for loop. So for I equal to 0, I less than n, I plus plus, and inside the for loop I will use the scanf function so that I can read the input from the user and store it into my array A. So it will be %d address operator A of I. So with this I can store the array. Then here I will print the unsorted array with the help of the printf function. So printf the unsorted array is, here I will use 2 slash n's so that I can give a considerable gap, and this quote should also be outside. And for displaying the unsorted array, I have to again use the for loop. So it will be, say, for j equal to 0, my other loop variable, j less than n, j plus plus, and inside the for loop I will use the printf function so that I can display the unsorted array. So %d, and to give a precise gap between the elements in the array, I will use the /t or the tab character, and here again I have to call my array by a of j. So with this we can take the user input for the size of the array, then we can tell the user to enter the elements one by one, and then we can display the unsorted array. Now let us try to run this program and check whether the program is working till now or not. Before that, let me use the return statement, because this function will be returning integer values. So now it's correct. Let me run it. Okay. So now let the size be 5, and yes, it's asking me for the 5 elements one by one. I will give 13, 24, 36, 17 and 12. So you can see that the unsorted array has been printed on the command prompt console. 13, 24, 36, 17 and 12. So our program is working correctly as of now. So let us go on and write the logic of the program. So first of all, let us write the swapping algorithm. So for that I will use a for loop, and I have two variables, as you can see, k and l, as you can see here. So I will take for k is equal to 0, k less than. Here I want to tell you something very important. We saw that when we have 5 elements in our array, in the fourth iteration we get our sorted array. So that means the looping or the iteration should be one number less than the highest element. So in that case it should be n minus 1. So here the value of k should be going on till k equal to 0 to k less than n minus 1, because in n minus 1 iterations we get our sorted array. So you need to remember this logic, otherwise you will be encountering errors in your program. Then I will use the increment, and inside this I will do the swapping algorithm. For that, first of all I have to use the if statement. So if a of k is greater than a of k plus 1, which will be the next element, in that case I will do the swapping. So inside the if statement, as I have declared the temp variable, what I will do is temp is equal to a of k, then a of k is equal to a of k plus 1, and finally a of k plus 1 is equal to temp. So this is a basic swapping algorithm. I hope you guys know about this, and I think I made a mistake here. So this will be a semicolon, and then with this we are done with the swapping algorithm, but this will be for the comparison of the numbers or the elements. But we also have to give a outer for loop for the number of iterations. So for this I will use another for loop, which is for l equal to 0, and as I showed you, the number of iterations will be n minus 1. So l less than n minus 1, l plus plus, and then we will start this for loop, and this brace will not be here, it will be after the end of the inner for loop. So for that, this is the inner for loop. So after this we will be using the outer for loop. So now this is done. Then finally, as we have printed the unsorted array, we will also be printing the sorted array. So for that, here I will again use the printf function, and I will type the sorted array after bubble sort is, and here, so that I can give the control to the next line, what I will do is I will use a slash n, and here also I will use two slash n's. So this is done, and to display the array I have to use a for loop. So for I equal to 0, I less than n, I plus plus, and here I will print %t, and to give a space between the elements I will give the slash t or the tab character, and finally I will call my variable, which is a of I. So with this we are done with the logic. So let us run the program and check whether it is working or not. So I'm running it, and okay, it's asking me for the size of the array. Let the size be 5, and let us take the earlier example only: 13, 24, 36, 17, and 12. So you can see the unsorted array is 13, 24, 36, 17, and 12, and after the bubble sort is done, it displays the sorted array after bubble sort is 12, 13, 17, 24, and 36. So this is it. Our program is working properly. So this is how you can use the bubble sort algorithm and sort an array in ascending order. I hope you guys have liked this video. Thank you.
So this is all about this video, guys. Thanks for watching. Hope you like the video, and if you like it, then tell us in the comment section below. If you have any doubts, then post them in the comment section. I will definitely try to clear those doubts. Also, like, share and subscribe to our channel Coders Arcade, and press the bell icon so that you will get a notification when we post a new video. Thank you. Happy learning.